Hi, welcome to Meetings in Math. You are here for section 10.7, Operations and Scientific Notation, and we're going to focus on adding and subtracting this time. Our essential question is, how is addition and subtraction performed with scientific notation? Today you are going to need your Jaguar dots on section 10.7a, a pen or a pencil. You might find a highlighter useful. In fact, you might find multiple highlighters useful today. A calculator could be useful in some calculations, but most of them are going to be done by hand. And then your bright ideas, your creativity, and always bring your problem-solving skills. So we're going to begin with just how we do this. We're going to outline some of our ideas, and then we're going to practice them. So addition and subtraction must have the same power of 10. In other words, when we're looking at the two numbers that we're going to add and subtract, we want to make sure that we have the same power of 10 with those numbers that are written in scientific notation. And if they aren't, we're going to rewrite one of them so that they are in the same power of 10. And that can get a little bit confusing, so make sure you pay close attention when we get to those problems. And then we're going to add and subtract the factors. That is the part that's not the power of 10. So you're just going to add and subtract those parts. And then we're going to make sure that our number is in scientific notation for the answer. And if it isn't, we're going to need to convert it until it is. And that's basically how we do these problems. It sounds kind of short and sweet, but there are some places where you can get hung up and have a little bit of confusion. So we want to make sure that you know how to do those. So let's go ahead and practice some problems. So on our first one, we're going to simplify 2.1 times 10 to the negative fourth plus 9.74 times 10 to the negative fourth. We're really lucky on the first one because we have 10 to the negative fourth and 10 to the negative fourth. So they are having the same power of 10. So what we're going to do then is add 2.1 and 9.74. But we want to rewrite these so that we understand where we're going in the problem. So remember, we write things out so that somebody reading our work understands where we came from, so that it's not just a mystery where the numbers came from. So let's go ahead and rewrite that. So you see that we're going to add 2.1 and 9.74, and then we just have to write that 10 to the negative fourth once. This is really called factoring what we're doing, but for us and our purposes, just remember you only have to write that 10 to the negative fourth once. So 2.1 and 9.74, when we add that, is 11.4. And just rewrite that power of 10 because we need to make sure that we have that so it's in scientific notation. So when I look at that number, it is not in scientific notation. So I need to make it into scientific notation. There are some people that can do this next step without writing anything down, and more power to them. I am not one of those people. So the first thing I do is I go ahead and I take that number and I make it into standard form. So I'm going to take that and make it into standard form. So I start by writing 11.84. And then it's to the negative fourth. So that means I need to move it 1, 2, 3, 4 places. And this is my new decimal place. So then I had to fill in my zeros. So that's my new number. So now I'm going to convert that into my scientific notation. So that means I need to take it, and I need to move my decimal place back so it has a number between 1 and 9 in front of the decimal. So now the decimal place is going to go 1, 2, 3 decimal places, and I can finish my problem now. So that's just a piece of scratch work that you can do on a piece of paper anywhere you want. It's not something you have to show. It's just something that for me, I almost have to do almost every single time. Another way that you can do it is you can take that number right there and convert it by saying, okay, well, I just know I need to make it one place. And so I could say 1.184 times 10 to the negative 1, and then write my 10 to the negative 4. And then I can use what I know about multiplying numbers with the same base. And so I can just add my exponents. And then I have 1.184 times 10 to the negative 3. So those are both very valid ways to do it. Both of them are perfectly fine to do. I like doing it the way I showed you when I hand wrote it. It's very visual for me. It makes a lot of sense. The way I showed it here, mathematically makes a lot of sense, and both of them are valid ways. So in this one, I have 4.7 times 10 to the 5th minus 7.2 times 10 to the 3rd. So if I look at this one, I have a 10 to the 5th and a 10 to the 3rd. These are not the same. That is problematic. So remember the rule said that they had to have the same 10 power, 10 to the same power, which means I need to do something to make that happen. So I'm going to go ahead and leave my 4.7 times 10 to the 5th what it is. And I'm going to convert my 10 to the 3rd power to something to the 5th power, 10 to the 5th power. What that means is I'm going to convert this right here into something new. And then it's going to say times 10 to the 5th. So what I want to do is I want to think of a number that I can do to 3 that will end up being 5. So it's the easiest if I just show you. So what I do is I convert this. I know that if I use my rules for exponents, -2 plus 5 is 3. And so I convert this right here into 7.2 times 10 to the -2, and I put that in parentheses, times 10 to the 5th, because this right here, I need to have left in place. So now what I'm going to do is I'm now going to convert this into that new decimal. So I leave this alone because I haven't done anything to that. And I convert that into the new decimal. And so this is 0.072 as the new decimal because it went 2 places. Times 10 to the 5th. This didn't change. But what I have now is I have powers that are the same. So this is my new number. It's still the same value of this. It just looks very different. It has the same 10 to the 5th. It just looks different. And now I can take my 4.7 and my 0.072 and I can subtract those. And now I have a 10 to the 5th and a 10 to the 5th, and I can have my 10 to the 5th on the outside. So now 4.7 minus 0.072 is 4.628 times 10 to the 5th. So this can be really hard. You just have to think to yourself, it needs to be this in the end. So when you're doing this conversion, you need to think to yourself, it needs to be this in the end. So what do I need to do to this to make that happen? And then those are going to be the 2 things you put out here. So let's go ahead and try another one with that same idea in place. You can see right here that our power of 10s are not the same. We have a 10 squared and a 10 to the -1. For whatever reason, I almost always just use the second one. So what do I do to -1 to make it 2? Well, if I need to make it 2, if I went 3 minus 1, that would be 2. So I am going to take and leave the first one the same. And then I'm going to take the second one and I'm going to split this right here so that it says 10 to the -3rd plus times 10 squared, because I have to have the last thing to be 10 squared so that it matches this 10 squared. But when I put 10 to the 3rd times 10 squared, it's equal to 10 to the -1. Those 2 things right there equal 10 to the -1. That's what you always have to check for, is that these 2 equal what it was before. You have to also check that this and that last one are the same so that you can later do the addition. And they are. So now we have our 8 times 10 squared plus, and we're going to take our 3.41 times 10 to the -3 and turn that into a decimal. So turn it into its standard form. So 0.00341, because you had to move it 3 places. So it was here, and we went 1, 2, 3 times 10 squared. This 10 squared just dropped down. So now we have that number right here that we needed. So now we're going to take our 8.2 and our 0.00341, and we are going to add them. Why are we adding them? Because it's an addition sign right here. And then times 10 squared, because it's a 10 squared right there. So when we add those, we get 8.20341 times 10 squared. So once we get the messiness of getting the power of 10 right, add those factors and then make sure that you have the right power. Okay, we would like you guys to try this one on your own and then come back and see how you did. So this one didn't have nearly the messiness that the other ones did. We have both 10 to the negative fifths. That's good news. When we have those same ones, we get to just move on. So we're going to keep that 10 to the negative fifth. So we have our 7.8 minus. Why is it minus? Because it's a minus right here. So 7.8 minus 4.5 times 10 to the negative fifth, because these were both 10 to the negative fifths. So now 7.8 minus 4.5 was 3.3, and the 10 to the negative fifth comes along. Make sure that you put the times in between because it is scientific notation. So that's how you add and subtract scientific notation numbers. What I would like you to do is explain to somebody how to add and subtract scientific notation numbers, especially when the power of 10 is not the same. When you can explain to somebody how to do something, you can understand it even better. Thank you so much for joining in this video, and I can't wait to see you in the next video when we talk about multiplication and division. Thank you so much for showing up, and remember, be kind to one another because we can all use some extra kindness in our lives. Bye for now.